geobyte.
Similarly, let us take the another important problem. Okay, look at the screen. It is asking like this. The acceleration due to gravity at a height 1 kilometer above the earth is same as at a depth d below the surface of the earth. It is given like this. Let g dash equal to acceleration due to gravity at a height h. That g dash equal to g into 1 minus 2h by r. Similarly, g double dash equal to acceleration acceleration due to gravity at a depth d, that is equal to g into 1 minus d by r. But it is given that acceleration due to gravity at a height g dash equal to acceleration due to gravity at a depth d. That means g dash equal to g double dash. This is the condition given. This is the condition given. Okay. Now let us take another slide. Here g dash equal to g double dash. G dash equal to what? G into 1 minus 2h by r is equal to g into 1 minus d by r. Now compare it. Here g 1 1 r r, then d equal to h. But what is the height given? Look at the height given. Height given is 1 kilometer. H equal to 1 kilometer. It is equal to 2 into 1 kilometer equal to 2 kilometers. So acceleration due to gravity at a depth 2 kilometer equal to acceleration due to gravity at a height 1 kilometer. Option D is absolutely correct. Understood clearly? Yes. Then let us take the another important problem. Asked like this. A satellite of mass m is orbiting the earth at a radius of r. The earth means that earth radius is given r at a height h from the surface of the earth. The total energy of the satellite in terms of g naught. Here total energy of the satellite, let that is E equal to minus g capital M small m by 2r, where r equal to r plus h, because it is given the satellite is orbiting at a height of h from the surface of the earth. Okay, right? It can be written as minus g capital M small m by 2 into r plus h. But as you know, it is given the total energy of the satellite in terms of g. G naught equal to what? G naught equal to gm by r square. Gm by r square. From this gm equal to g naught into r square. So in the place of gm, you can write the g naught r square e equal to minus gm equal to g naught r square into m by 2 into r plus h. Can also written as minus m g naught r square by 2 into r plus h. Now look at the option. Look at the option B, m g naught r square by 2 r plus h. Option D is option B. Option B is absolutely correct. Okay. Similarly, let us take the another important problem. Ask like this. At what height from the surface of the earth the gravity potential and value of G are minus 5.4 into 10 power 7 joules per kg square, and this acceleration due to gravity. It is given that gravitational potential gravitational potential. Gravitational potential you can mark with the V is equal to, as you know, minus Gm by R plus H, that is given as minus 5.4 into 10 power 7 joules per kg square. And acceleration due to gravity, G is given 6, but G equal to what? Gm by R plus H whole square. From this, Gm equal to 6 into R plus H whole square. Therefore, the 5.4 into 10 power 7, that is V value, gravitational function, equal to Gm. Gm equal to what? 6 into R plus H whole square by R plus H. Here 1 R plus H is cancelling. Final it is 5.4 into 10 power 7 is equal to 6 into, look at the radius of the earth given, 6400. Radius of the earth is 6400 kilometers. That is equal to 6.4 into 10 power 6 meters. Okay, 6.4 into 10 power 6 plus h. From this we decide h value. This h value I got 2600 kilometers. That's the answer. Look at the option A. Option A is absolutely correct. Understood clearly? Yes, it is very easy problem. Okay. Similarly, let's take the another important problem. Okay. Look at the screen. It is asking like this. The ratio of escape velocity at Earth to the escape velocity at planet whose radius and mean density are twice as that of the Earth. You are asked to decide the escape velocity at Earth divided by escape velocity at the planet is how much. For that, the given conditions are the density of the planet equal to 2 times the density of the Earth, and the radius of the planet equal to 2 times the radius of the Earth. For that, we should know the basic formula for deciding the escape velocity. The escape velocity V equal to root over 2gm by R. But density relation given means it is better to write mass in terms of density. As we all know, density rho equal to mass by volume. From this, mass equal to density multiplied by volume. It is equal to density multiplied by volume is 4 by third pi r cube. That is the sphere density or sphere volume. Then the escape velocity equal to root over 2g, in the place of m, write that value, rho into 4 by third pi r cube divided by r. It can be also written as v equal to root over 2 into 4 by third into pi into j into rho. One r will be cancelled. One r will be cancelled. Here it is r square. Okay, but it is given only the density variation and radius variation. From this, I can say that the escape velocity is directly proportional to root over the rho and r square, because g remains constant. From that, I can write that escape velocity divided by root over rho r square is proportional to 1, or the escape velocity divided by root over rho r square is a constant. Okay, from that, escape velocity divided by root over rho r square rho r square for the earth equal to escape velocity divided by root over rho r square for the planet. From this, I can write that escape velocity at the earth divided by escape velocity at the planet is equal to root over rho for earth r for e square divided by rho for the planet into r for planet whole square. Listen carefully. It is equal to root over density of the earth into radius of the earth whole square divided by, given that density at the planet equal to 2 times the density at the earth, and radius of the planet equal to 2 times the radius of the earth. Let us substitute 2 rho e into 2 re whole square. Now you simplify it. It is equal to it is equal to rho e into re whole square divided by 2 into rho e into 4 into re square. This re square cancelled, rho e cancelled. Finally, it is equal to 1 by 8. 1 by 8 can be written as 1 by 2 root 2. That is the ratio between the escape velocity at Earth divided by escape velocity at the planet. From this, I can write that escape velocity at the Earth is to escape velocity at the planet equal to 1 is to 2 root 2. That is the answer. 1 is to 2 root 2. Look at the options. Look at the option B. Option B is absolutely correct. Understood clearly? Yes.
Geobyte.